Applications with absolute value function notes. So these notes are going to be about the applications or real-world problems using absolute value functions. So example 1 says, in a cheerleading competition, the minimum length of a routine is 4 minutes. So minimum length, 4 minutes. The maximum length of a routine is 5 minutes. Maximum, 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. For the notes, we went ahead and broke it down. So our first step is to identify the minimum and maximum. We know that the minimum is 4 minutes and the maximum is 5 minutes. Step 2 says, consider the minimum and maximum lengths as solutions to the absolute value equation. Use the number line to find the halfway point between the solutions. So we are going to plot the minimum value of 4, and then we're going to plot the maximum value of 5. So if we were to find the middle of that, the middle of 4 and 5 would be 4.5. So using that middle point and the distance to each solution, write an absolute value equation for your situation. So we know that our halfway point is 4.5. And if we were to calculate the distance from our minimum to our midpoint, and then our midpoint to our maximum, we would see that the distance would be 0.5. What this means is that if we take 4 plus 0.5, we get our middle value. Okay? And if we take 5 and subtract 0.5, we get our middle value. So the distance is equal to 0.5. So writing this as an equation, we are going to take the absolute value of x minus our halfway point, so 4.5, absolute value equals our distance, 0.5. Before we can consider this our answer, we have to check in step 4 by substituting our minimum and maximum lengths back in. So I'm going to do my check. So I'm going to first check my minimum, which was 4. So I'm going to do absolute value of 4 minus 4.5 is equal to 0.5. 4 minus 4.5 is negative 0.5 is equal to 0.5. When we take the absolute value, it gets rid of that negative, so we have 0.5 is equal to 0.5. This is a true statement, so it checks out for the minimum value. Now we are going to check the maximum value of 5. So we have the absolute value of 5 minus 4.5 equals 0.5. Well, 5 minus 4.5 is 0.5 is equal to 0.5. Absolute value means it stays positive, so I have 0.5 is equal to 0.5, which again is a true statement, so that one checks out as well, meaning this is our equation that represents the situation in example 1. Example 2 says, for a poetry contest, the minimum length of a poem is 16 lines. So I'm going to highlight that minimum 16 lines. The maximum length is 32 lines. Maximum 32 lines. Write an absolute value equation that represents the minimum and maximum lengths. So remember, first we identify them. So our minimum is equal to 16 lines. And our maximum is equal to 32 lines. Now we're going to plot that 16 and 32. So here we have 16, then we have 32, and then we need to find the midway point between 16 and 32. So the middle one between that is going to be 24. So this is the halfway at 24. And if we were to calculate the distance between the minimum and the half point and the maximum, we should get the same distance. And that distance here is 8. So again, this is saying if we take our minimum value, 16, and we add our distance, 8, we'll get our halfway point of 24. And then opposite, if we take our maximum value, 32, and we subtract our distance, 8, we get our halfway point of 24. These distance should be the same because we are finding the halfway point between the two. Okay, so halfway is equal to 24 lines. Our distance is equal to 8 lines. So if we were to write an equation, we would have the absolute value of x minus our halfway, so minus 24, is equal to our distance, which is 8. And then before we can say this is our answer, we have to first check our minimum and our maximum. So checking the minimum, which we know is 16, we're going to do the absolute value of 16 minus 24 is equal to 8, which gives us absolute value of negative 8 is equal to 8. Absolute value makes it positive, so 8 is equal to 8 is a true statement. So that one checks out. And then I'm going to check the maximum, which is 32. And we have the absolute value of 32 minus 24 is equal to 8. 32 minus 24 is 8. Absolute value of 8 is still 8, so we have 8 equals 8, which again is a true statement, so that checks out, meaning this is our equation that represents the situation in example 2.